All right, let's dive into something pretty wild today. We're looking at a new theory that basically says cosmology has been on the wrong track for decades. It's a theory that claims the biggest mysteries in the universe, dark matter and dark energy, well, they don't even exist. Instead, it offers a solution that's all about geometry. Let's get into it. So, you've heard the numbers, right? Our best model of the universe says about 95% of everything is made of some kind of dark stuff that we can't see or touch. We call it the dark sector. But what if it's not missing at all? What if we're just looking at the universe through the wrong lens? What if the problem isn't with the cosmos, but with our theories? You see, the reigning champion of cosmic theories is what we call the Standard Model of Cosmology, or Lambda CDM for short. It's been incredibly successful for sure, but it has a bit of a secret. To get the math to line up with what we see out there, we have to invent two giant, mysterious things. Dark matter, which provides the extra gravity to keep galaxies from flying apart, and dark energy, which is the force pushing the entire universe to expand faster and faster. And this right here really shows the clash in philosophy. On one side, you have the Standard Model. It's what we call a descriptive fit. That means it works by looking at the universe, taking measurements, and then tuning more than 20 different knobs or parameters until the model matches reality. But on the other side, you have this Unified Chronofractal Field, or UCF. It proposes something completely different. It says there are 0 knobs to turn. Everything, absolutely everything, should just emerge from two basic mathematical constants, the golden ratio and pi. It's not a description, it's what they call a geometric inevitability. So how on earth can a theory run on just geometry? Well, the whole UCF model is built on just two foundational ideas, or axioms. It basically throws out the need for any new particles, and instead rewrites the rules for space and time themselves. This quote really gets to the core of it. It's such a bold, elegant demand. The idea is that physics shouldn't be about chasing mysterious substances to plug into our equations. No, it should be a branch of geometry, where all the rules of the universe just pop out naturally from the fundamental shape of reality. Okay, so this first axiom is a real mind-bender. It says time isn't like a river, just flowing in one direction. Instead, you should think of it more like a crystal that's constantly growing, or a tree that's always branching out. It's a fractal process. And this growth is governed by the golden ratio. It's this natural geometric expansion of time itself that creates the push, the accelerating expansion that we've been calling dark energy. So dark energy isn't a thing. It's just the universe getting more complex. Now for axiom 2, which takes on dark matter. It says that as the influence of gravity spreads out in 3 dimensions, its effect gets watered down by the simple, inescapable geometry of a sphere. Think about how a sound gets quieter the farther you are from the source. It's kind of like that. And this damping effect isn't some made-up number. It's exactly 1 divided by pi. So that extra gravity we see holding galaxies together, it's not from invisible stuff. It's just a fundamental geometric rule of 3D space that we've been missing all along. All right, so you take these two ideas, fractal time and topological space, and you put them together, you get something completely new, a totally wild property of matter that they call historicity. And this is the absolute key. In the UCF model, information literally has gravitational weight. The longer a system, like a star or a galaxy, has been around in a stable form, the more information age, or historicity, it builds up. It's like it carves a deeper groove into the fabric of space-time. This means old things pull harder than young things of the exact same mass. Gravity isn't just about how much stuff there is, it's about how long that stuff has been around. Okay, so if you're a theory that wants to kill dark matter, you have to face the final boss, and that's the bullet cluster. This is a famous collision of 2 galaxy clusters, and it's pretty much considered the smoking gun, the absolute best proof that dark matter is real. Why? Because after the crash, the gravity and the normal matter are in 2 totally different places. And that's the million-dollar question, right? If there's no invisible matter, then what in the world is pulling on things way over here, when all the gas we can see is way over there? The Standard Model says easy, it's a giant blob of dark matter that just passed through the crash like a ghost. But UCF has a very, very different answer. Let's break down the UCF explanation, step by step. Before the collision, you've got your 2 clusters heading for each other. Each one has stars that are billions of years old. They have incredibly high information age, or historicity. They're like deep anchors of information. And surrounding them are these huge clouds of hot gas, which is way more chaotic and has a much lower, more moderate historicity. Then comes the impact. The stars themselves are like tiny bullets. They're so dense and far apart, they mostly just fly right past each other. But the enormous clouds of gas, they can't. They slam into each other in the middle, creating a violent, massive shockwave. And this is the crucial moment. UCF theory says this shockwave acts like wiping a hard drive. It totally scrambles the information state of the gas, effectively resetting its age to zero. They call this an entropic reset. And boom, here's the solution. The gas gets slowed down by the collision, sure, but way more importantly, its gravitational pull gets temporarily nerfed because its historicity has just been wiped clean. Meanwhile, the stars sailed right on through, with their ancient information age totally intact. And since gravity follows historicity, the center of gravity just stays with the old stars, not the now young gas. The separation isn't weird at all. It's a natural result. So the takeaway here is really simple. The bullet cluster isn't showing us a ghost of dark matter. It's showing us a memory. Gravity is just following the part of the system with the deepest, oldest history, the ancient stars, while the gas cloud, its memory wiped clean by the crash, gets left lagging behind. Now look, a cool story is one thing, but this is science, and science demands proof. What makes a theory like UCF really interesting isn't just that it explains old mysteries, but that it makes bold, specific predictions that can be tested. It has to be willing to be proven wrong. And UCF makes some predictions that are just jaw-droppingly specific. Get this. The theory predicts that because time is fractal, there should be a tiny time drift of exactly 61.9 microseconds every year in the communication signals we send between Earth and Mars. And it claims this signal is already in the data from the Deep Space Network, but that our computers are programmed to see it, think it's just random clock noise, and filter it right out. This is what I love to see, a real head-to-head showdown. Look at dark energy. The standard model says it's a perfect constant, minus 1.00, and it never changes. UCF predicts a different value, about minus 0.794, and says that value should actually be changing over time. Or look at how galaxies rotate. The standard model doesn't have one answer. You have to custom fit a dark matter halo for every single galaxy. UCF predicts one single universal number for all of them, 1 over pi. They predict completely different things. And the best part is, we don't have to wait forever to find out who's right. The Euclid Space Telescope, which just launched, is designed to measure dark energy with unbelievable precision. Its data is going to be the ultimate judge. The results will either cement the standard model for another generation or spark a complete revolution in cosmology, maybe even proving this wild geometric idea right. So in the end, that's the real question this whole theory leaves us with. For a century, we've pictured the universe as a giant, dark container full of particles and forces. This new idea asks us to imagine something profoundly different, a universe that isn't a container at all, but a process, a geometric, self-organizing system where time itself is the engine of creation. And the answer could be waiting for us in the very next batch of data from deep space.
Welcome back to the Deep Dive. You know how this works. We take the densest, most complex documents you send us, the research papers, the white papers, and we do the work for you, distilling it all down to give you that real, nuanced understanding.
And today, we are really pushing the boat out.
We really are. We're strapping in for a journey into something genuinely radical. This is a document that claims to have unified gravity, dark matter, and dark energy. All of it. Into a single geometric theory.
That's right. We are stepping, I think it's fair to say, well out of the safe harbor of conventional physics. We're looking at the Unified Chronofractal Field Theory, or UCF.
And we're looking at version 6.0, which they are calling the zero-parameter limit.
Which is a very bold claim. This isn't just a new theory, it's a whole new philosophy of what physics should be.
And the claim here is it's massive. This document argues that the entire dark sector, the 95% of the cosmos we can't see, all that dark matter and dark energy.
Yeah, all of it.
It's not made of some exotic new particle we haven't found yet. It's, and I'm quoting here, a geometric inevitability. Something built from math we've known about since, ancient Greece.
It's an incredibly audacious claim, but it's rooted in this idea of parsimony, of simplicity. The current model we use, the standard model, or lambda CDM,
right.
It's a triumph of description. It matches what we see almost perfectly. But the UCF paper argues it's an explanatory failure.
Because of all the knobs you have to turn.
Exactly. It needs at least 20 free parameters. These are numbers you have to go out, measure from the cosmos, and then plug into the equations by hand. The density of dark energy, the density of dark matter, and so on.
So if lambda CDM is this super complex 20-knob stereo system that you have to tune perfectly to get the right sound,
A great analogy.
and UCF version 6.0 is claiming to be the fundamental tuning fork. It says it has eliminated its last empirical parameter.
It has. The claim is that the entire universe is grounded in just two purely mathematical constants. Nu, which is the golden ratio conjugate, and, well, pi,
The circle constant.
the circle constant. The master equation of the universe, according to this theory, is defined only by those two numbers. It's a declaration that physics must, at the end of the day, become a branch of geometry. Constants shouldn't be measured, they should be derived.
Okay, let's unpack all of that. Our mission for you today is to really get to grips with the consequences of this idea. We need to understand how on Earth the golden ratio and pi can explain why the universe is expanding faster and faster.
And maybe the biggest test of all.
Right, the big one. How this geometry can possibly resolve the most difficult puzzle for any theory like this. The bullet cluster. That's where you see gravitational mass and visible mass literally pulling apart from each other. This deep dive is all about geometry as destiny.
It really is.
So the starting point for this whole UCF paper is something they call the crisis of parameters.
Right.
With lambda CDM, you need all these inputs, right? The shape of a dark matter halo, the exact ratio of dark to normal matter, the rate of dark energy's acceleration. They fit the data beautifully, but they don't predict anything from, first principles.
Exactly. The whole mandate of UCF is to get rid of that. To produce a theory with zero free physical parameters. They argue that if you have to measure a constant to plug it into your equation, your theory is, by definition, incomplete.
So every constant we see in nature has to be some kind of rigorous mathematical outcome of spacetime's geometry.
It's about replacing empirical measurement with unavoidable math.
So the geometry is the engine of everything. Let's get into it. What are the two big axioms that are driving this entire cosmic framework?
Okay, so the first one is all about time. It's a geometric axiom defined by the constant nu.
The golden ratio conjugate.
That's the one. It's about 0.618034. And it comes from a very, very simple quadratic equation. Nu squared plus nu minus 1 equals 0.
Well, wait. Why the golden ratio? I mean, that's the thing you see in art and seashells and architecture. Why is that fundamental to physics?
That's the billion-dollar question, isn't it? The theory's answer is that it represents the most efficient possible relationship for self-similarity, for growth. UCF posits that nu is what's called a renormalization fixed point for any system that is trying to optimize how it retains information.
Okay, that's getting very abstract.
It is. Think of it like this. The universe is a self-referential process. It's constantly crystallizing information. And for that to happen efficiently, the geometry of the universe at every single scale has to strike a perfect balance between creating new information and holding on to its accumulated history.
And that leads to a fractal dimension for time. I'm trying to connect those dots.
Right, because the standard idea in general relativity is that time is just a simple 1D line, a smooth road from past to future.
Yeah.
UCF says that's too simple. If time is constantly optimizing its own information density, it has to have structure embedded within it, self-similar structure. And that self-similarity is what defines its fractal dimension.
Which they define as d sub t equals 1 plus nu.
dt1 plus nu, exactly. The 1 is normal time, and the nu is this extra fractal depth.
So that fractal excess, the new part, that's the engine.
That's the engine, precisely. This tiny bit of extra dimensionality, this fractal structure in time, is what generates a persistent negative pressure.
And that's what we observe as dark energy.
That's what we observe as dark energy. The rate the universe is accelerating isn't from some mysterious energy floating in the vacuum. It's a structural requirement built into the very fabric of time itself, all governed by the mathematics of optimal information flow.
So dark energy is just the geometric pressure from the universe trying to grow efficiently.
That's the conceptual bridge, yes.
Okay, that's the engine of time. Let's talk about the limit of space, the part governed by pi. Because this is where version 6.0 made its big breakthrough, right? Getting to that zero parameter limit.
This was the huge step.
Because before, they had to sort of fit a number by hand, this mass damping coefficient eta, to explain how gravity worked in galaxies. And the number was around 0.32.
It was. And that was the theory's weak spot, its last adjustable knob. The V6.0 derivation is what changed the game because it elevates eta from just a fitted value to a mathematical necessity. The researchers realized that any gravitational influence, any information radiating from a mass has to spread out. And in 3D space, it spreads out spherically.
Like ripples on a pond, but in 3 dimensions, the law of information dilution.
Exactly. And when you look at the topological rules for how information density thins out over a 3D volume, the relationship between a sphere's radius and its surface area, well, it naturally involves pi.
Of course.
So the dilution of that information must follow a very specific scaling factor. There's no other choice.
And that factor is the topological damping identity. Eta is simply 1 over pi.
Yes. And since pi is roughly 3.14159, 1 over pi is about 0.3183.
Which is almost identical to their old empirical fit of 0.32.
The difference is less than 0.6%. It's an incredible lockdown. It moves from this number seems to work to this number is mathematically required.
So what we've been mapping is dark matter halos around galaxies. It isn't a cloud of invisible particles at all. It's the observational shadow of this geometric dampening effect.
It's the dilution of information governed by pi. If nu drives the growth of the universe through fractal time, pi dictates the limits of that growth in physical space.
Okay, so if we accept these two axioms, nu for growth, pi for the limit, how do they come together in the master equation that actually tells us how gravity works?
They unify into something called the chi field. That's the effective gravitational potential that, at large scales, takes over from the standard Newtonian potential.
The chi field.
Right. And the master equation just shows how this potential scales. And it has two main parts. You've got the kind of fractal scaling term, which goes as tau to the nu, where tau is cosmic time.
Regulated by the golden ratio.
And then you have the spherical damping term, which is proportional to m to the minus 1 over pi.
Regulated by pi. So the mass of a galaxy determines its gravitational reach, but that reach is damped by the geometry of space and then sort of modulated by its age in fractal time.
That is the core mechanism. And the absolutely crucial point here, what makes V6.0 so powerful, is that this master equation has 0 free physical parameters.
None.
It uses Newton's constant, g, of course, but that's just a unit scaling constant. It defines what we mean by gravity. It's not a descriptive parameter you have to fit. The entire dynamics of the universe are fixed purely by the values of nu and pi.
Which means every single prediction this equation makes is a direct, testable outcome of pure geometry. There are no knobs you can tweak to make the data fit. It either works or it doesn't.
It lives or dies by its predictions.
All right, so let's put that 0-parameter geometry to the test against the biggest thing we know, dark energy and the accelerating expansion of the universe. If this geometry is really fundamental, it has to predict the dynamics of the entire cosmos.
And this is where the theory makes, I think, its most profound shift. As we said, UCF doesn't see dark energy as a substance. It's a geometric artifact.
It's the pressure that shows up because our math is too simple.
Exactly. It's the pressure that arises because we are trying to model a universe with a fractal time dimension, dt equals 1 plus nu, using the math of general relativity, which was built for a simple one-dimensional time.
So GR is basically picking up the pressure differential caused by that missing fractal bit.
That's a perfect way to put it.
Now, standard cosmology uses this parameter, W, to describe dark energy. And a value of W equals -1 defines the cosmological constant, the lambda CDM model. It means the vacuum energy is static, unchanging.
Right. And UCF says that static condition is strictly forbidden by its geometry.
Why?
It's because of a principle the theory calls the third balance. The negative pressure comes from that fractal excess in time, from nu, but that pressure doesn't just push along the time axis. For the universe to be homogeneous and isotropic, which it is, that pressure has to be distributed evenly across all 3 spatial dimensions.
Oh, okay. That actually makes the derivation sound surprisingly simple. You're just taking the source of the pressure, nu, and dividing it by the number of spatial dimensions, 3.
Precisely. The derivation for the equation of state parameter today, which we call W0, is just W0 equals -1 plus nu divided by 3.
It's very elegant.
It is. And when you plug in the value for nu about 0.618, you get a non-negotiable geometric result. W0 is approximately -0.793989.
Just under -0.8. And what's so wild about that is that it's a prediction derived purely from math. There is 0 input from, messy observational data like supernovae or the cosmic microwave background.
And that's critical. It immediately puts the theory on a collision course with lambda CDM. If W0 is really -0.794, it absolutely cannot be -1.0. The geometric necessity for W0 to be greater than -1 means that if UCF is correct, the core idea of the cosmological constant is falsified.
So UCF predicts a dynamic vacuum then, not a static one. The expansion isn't fixed, it's changing over cosmic time.
It predicts what's called a thawing vacuum. In the standard model of dark energy, this change over time is measured by another parameter, Wa.
Right, and if WAS is 0, the vacuum is static.
And if Wa is positive, it means dark energy was stronger in the past.
So how does UCF get a value for WA without, again, just fitting it to observations?
It comes from the second-order dynamics of that fractal time dimension. The initial pressure comes from nu, but the change in that pressure, the evolution, comes from the squared term, nu squared.
It's like the kinetic component of the fractal scaling.
That's a good way to think of it, yes. It represents the self-referential change in the rate of growth. And just like with W0, this kinetic component has to be distributed over the 3 spatial dimensions.
So the derivation is y equals nu squared divided by 3.
Correct. And when you calculate that, you get a value of y is approximately positive 0.127322.
A positive value.
A positive value. And that is the signature of a thawing vacuum. It means the repulsive force of dark energy was actually stronger when the universe was younger, and it's been weakening or thawing ever since.
That's a huge conceptual difference. Lambda CDM says dark energy is just this constant, steady push. UCF says it's an aging, decaying geometric pressure.
And that brings us to what might be the highest stakes prediction in cosmology right now, the upcoming data from the European Space Agency's Euclid mission.
The Euclid trap, as the authors call it.
Yes, they've laid out a very clear falsification matrix. It's impressive, really.
It is. They've written their own kill switch right into the theory. That elevates this from just being a model to being real, testable science.
Absolutely. The whole point of the Euclid mission is to measure W0 and Wa with enough precision to tell the difference between a static W of -1 and these other dynamic models.
And the 2 predictions here couldn't be more different.
Not at all. On one side, you have the lambda CDM prediction. W0 is exactly -1.00, and Wa is exactly 0.00.
And on the other, you have the 0-parameter UCF prediction. W0 is around -0.794, and Wa is around positive 0.127. These 2 spots in the parameter space are completely separate.
There's no overlap.
So if Euclid's data comes back and the value for W0 is clustered right around -1.00, UCF is just dead in the water.
The authors call it condition red. If Euclid measures W0 equals -1.00 plus or -0.0002, UCF is strictly refuted. End of story. But conversely, if Euclid confirms the prediction of around -0.80, then lambda CDM, the bedrock of modern cosmology, is the one that's falsified.
And that would force a radical paradigm shift in how we understand the entire universe.
It would be the ultimate test. Geometric inevitability versus empirical fitting.
Okay, we've covered the cosmic scale. Now let's bring it down to the galactic scale. If this theory is going to work, it has to solve the other half of the puzzle. It has to explain why galaxies rotate the way they do without needing dark matter.
Right. The conventional view is that you need these huge, invisible halos of particles around every galaxy to provide the extra gravity to keep the outer stars from flying off.
But UCF throws that whole particle idea out.
Completely. And it replaces the concept of a dark matter halo with a mechanism called historicity.
We touched on this earlier, but we need to slow down and really define this because this seems to be the absolute linchpin of the whole theory.
It is. Historicity is a geometric property. You can think of it as the historical wake or the accumulated information density that a mass generates in the time dimension.
So in GR, mass warp space, in UCF, it also creates a kind of temporal memory, a history.
Exactly. And that accumulated history is the extra gravitational potential well. That's the chi field we talked about. It's what mimics dark matter.
I see. So the chi field isn't generated by invisible matter. It's generated by the sheer age and existence of normal baryonic matter inside this fractal time.
That's it. The unit of this density is the fractal information unit, or FIU. So older, denser systems like the core of a galaxy that's been around for billions of years.
They have deep historicity.
They've accumulated a vast amount of FIU. They have a very high chi field. And that high historicity is what creates this stronger, non-Newtonian gravitational pull that we've been misinterpreting as the dark matter effect.
Okay, let's connect that idea of historicity back to the other axiom we discussed, the 1/pi dampening. How does that dampening create flat galactic rotation curves?
Well, remember that the 1/pi factor is a hard rule of spherical information dilution. It means the gravitational influence, the chi field, generated by a mass, doesn't just fall off like 1/r², like Newton's law.
Right.
That influence is damped by this topological limit, m to the -1/pi.
So the geometry itself forces the gravitational pull to reach out further and stay stronger over longer distances than standard gravity would predict.
Precisely. And this geometric requirement leads to a really stunning result. It analytically derives the Tully-Fisher relation.
Which is one of the most solid empirical laws in galaxy dynamics, right? It connects a galaxy's rotation speed to its brightness.
It is. And the standard model has to use incredibly complex, messy computer simulations, tweaking halo shapes and feedback loops to try and reproduce it.
And UCF just pulls it out of the master equation.
Directly. The equation shows that the flat rotation velocity squared, v flat squared, scales in proportion to m to the power of 1 minus 1 over pi.
Okay, so 1 over pi is about 0.318. So 1 minus that is 0.682. So the velocity scales as mass to the power of about 0.34.
V flat is proportional to m to the bureau 0.34. That derived exponent, 0.34, lines up perfectly with what we observe in spiral galaxies. It reproduces this fundamental empirical law without any ad hoc adjustments. The structure of a galaxy is just fixed by the geometry of space.
Let's make this concrete. The source material uses the Andromeda galaxy M31 as a test case.
It's the perfect text-up test, yes. The goal is to predict its rotation velocity using only things we can actually see and measure, plus the 2 geometric constants.
So what are the inputs?
Just 2 things. The galaxy's visible baryonic mass, which is about 1 to 1.3 times 10 to the 11 solar masses, and its age, which is roughly 10 billion years.
You feed just those 2 numbers plus nu and pi into the master equation. What does it spit out?
It predicts a flat rotation velocity for Andromeda of somewhere between 220 and 240 kilometers per second.
And what's the actual measured observation?
The observation is about 225 plus or minus 20 kilometers per second.
That's incredible. The prediction is sitting right in the middle of the error bars. And it was derived using geometry and age without assuming a single dark matter particle exists.
It implies the entire gravitational map of our biggest neighbor is defined by the golden ratio in pi. It's the ultimate example of minimum description length. The simpler 0-parameter model gives a better explanation than the complex 20-parameter one.
Okay, here we go. This is where it gets really interesting. The bullet cluster.
The ultimate stress test.
It's often called the smoking gun for dark matter because most modified gravity theories just completely fail to explain it. If UCF can solve the bullet cluster, that changes the entire conversation.
The challenge is the separation, right? You have 2 galaxy clusters that flew through each other. The hot gas, which is most of the visible mass, is sticky. It collided in the middle and slowed down.
But the stars, the galaxies themselves, are basically collisionless. They just sailed right through. And the critical part is that gravitational lensing shows the center of gravity stayed with the stars, not with the gas in the middle.
Exactly, and Lambda CDM explains this easily. The invisible dark matter halos, also being collisionless, just traveled along with the stars, leaving the visible gas behind. Gravity follows the invisible matter.
So how does UCF, with no dark matter at all, explain why the gravity is separated from most of the visible mass?
The mechanism is, I think, very elegant. It's differential historicity combined with an entropic reset. The separation is a phenomenon of the time domain, not a particle phenomenon.
Okay.
To really get this, let's actually visualize it. Let's pretend we're designing the infographic that explains this. The title would be something like, Resolving the Bullet Cluster, the UCF Geometric Solution.
No dark matter required, in big letters.
Of course. And the style is clean, high-tech, like a blueprint on a dark background.
So panel 1. The setup. Pre-collision, we see 2 clusters approaching, and we have color coding, right?
Color coding is key. The stars and galaxies glow gold or orange. That represents their maturity, their high historicity. The gas clouds are a bright blue or cyan haze.
And the labels here are establishing that baseline. Pointing to the gold stars, the label says, high historicity systems, deep information anchor.
Because that's their geometric strength. They're old, condensed packets of information, huge reserves of FIU. And then pointing to the blue gas. Fluid matter, moderate historicity. It's less condensed, less historically anchored.
Then comes panel 2, the impact, the entropic shock. The gold stars are flying past each other, no problem. But the blue gas clouds slam into each other in the center. A huge, turbulent shockwave.
And this is the critical moment. We need a huge, maybe even flashing label right over that colliding gas that says, entropic reset event.
An entropic reset. What does entropy have to do with gravity?
Because the chi field, the source of the geometric gravity, is defined by information density. A high entropy event, like a violent shock wave, scrambles the local information state of the gas. It's thermodynamic chaos.
So the sublabel would explain that. Shockwave scrambles local information state, temporary drop in effective historicity.
Exactly. The gas has its local historical memory wiped clean, or at least reset, by the shock, so it temporarily loses its ability to generate that strong non-Newtonian gravity.
But the stars, they're collisionless. They don't experience the shock. Their history, measured in billions of years, is intact. Their chi field potential stays high.
Precisely. The separation is caused by this differential in historicity. The gas loses its geometric gravity potential while the stars keep theirs.
Which brings us to panel 3, the aftermath. The clusters have passed through. The blue gas is stuck in the middle, slowed by friction, and its history being reset. The gold stars are way out on the sides.
And this is the aha moment. We show the gravitational lensing grid, that purple distortion centered on the stars, not the gas.
And the final labels drive it home, pointing to the stars. Gravitational peak here. Subtext. Gravity follows maximum historicity, not just mass.
And pointing to the gas. Offset gas cloud. Subtext. Slowed by friction and entropic reset.
So the whole thing is explained. The final conclusion box would say the separation isn't caused by invisible particles, but by the difference in information age between the stars and the gas during this entropic shock.
It turns the biggest challenge for modified gravity into its most powerful piece of evidence. It's an information theory solution, not a particle physics one.
That is a phenomenal way to reframe the problem. But okay, if this fractal time idea is real, its effects have to be measurable closer to home, right? Not just in distant galaxy clusters. It has to show up here in our solar system and even at the quantum level.
Absolutely. A theory that only works in deep space is just a model. For it to be fundamental physics, it has to work everywhere.
So let's talk about the solar system. Critics of modified gravity usually look for errors in trajectories.
Yeah.
Is Pluto where it's supposed to be? But UCF makes a much more subtle prediction. It's not about the trajectory channel. It's about the clock channel.
Exactly. Standard GR is fantastic at predicting orbital paths, but it assumes that time flows perfectly smoothly, that d tau over d tau equals 1. UCF says the local flow of time is slightly disturbed by this chronofractal effect. It's more like d tau over dt is 1 plus some tiny epsilon. Now that epsilon is far too small to noticeably change where Mars is in its orbit.
But it will accumulate over time.
As a metric drift in the timestamp of the signals we use to communicate with it.
So we're looking for a cumulative timing error in the deep space network signals, specifically for the link between Earth and Mars.
Yes. The math is pretty direct. You have to calculate this coupling factor, epsilon UCF, which connects the local gravity to the constants nu and pi. The derivation gives a value of about 0.001376.
And we apply that factor to the known time dilation effect from general relativity.
Correct. The standard GR time dilation for the Earth-Mars link is already known. It's about 45 milliseconds a year, or 45,000 microseconds per year. That's just the normal effect of space-time curvature.
So the UCF prediction is at 45,000 microseconds per year times 0.001376.
Which gives you a single, very specific zero-parameter prediction, a cumulative drift of 61.9 microseconds per year. That is the measurable signature of fractal time in our solar system.
61.9 microseconds a year. That is an incredibly tiny number. How have the DSN navigation teams not found this already?
Because of how they clean their data. This tiny signal shows up as a linear frequency bias in the Doppler signals, and the Deep Space Network uses incredibly sophisticated algorithms, Kalman filters, to get the highest quality data.
And those filters are designed to remove noise.
They're programmed to see any linear frequency bias, whether it's from an aging clock oscillator or something else, as noise, and they filter it out. They zero the drift.
So the theory is basically telling NASA and the ESA, stop cleaning your data so well.
That is the critical warning in the paper. Do not zero this drift. If they go back and analyze the raw Doppler data without that specific filtering step, this 61.9 microsecond per year drift should be sitting right there. It would be a laboratory scale confirmation of time being governed by the golden ratio.
That's amazing. But what about even smaller scales? How does a geometric theory about time connect all the way down to the quantum realm? How does fractal time change how virtual particles behave?
We can look at vacuum fluctuations, specifically the Casimir effect.
That's the tiny attractive force between two metal plates in a vacuum room.
It is. And standard quantum electrodynamics, QED, which assumes a normal 4D spacetime, predicts that this pressure scales with the distance, d to the power of -4.
But if time is fractal, the effective dimensionality of the vacuum itself is slightly higher.
Precisely. The fractal depth of time has to be factored in. The UCF derivation says the scaling exponent gets enhanced by 2 nu. The factor of 2 is there because vacuum fluctuations are energy fields that couple to both the forward and backward flow of time, creating standing waves in this complex temporal dimension.
So the exponent changes from 4 to 4 plus 2 times nu.
Which is 4 plus 2 times 5.1618, so about 5.236. The prediction is that at extremely small scales, the Casimir pressure should scale closer to d to the minus 5.23.
That's a testable deviation from the standard model. But it would require a special experiment, I'm guessing.
It would. You'd need a specialized device, something they call a fractal MEMS resonator, where the plates themselves are etched with a fractal pattern to enhance this coupling to fractal time. If that experiment confirms the scaling is closer to minus 5.23 than -4, it's another laboratory proof.
Okay, one more. The muon G2 anomaly. This has been a huge source of tension in physics for years. The muon wobbles in a magnetic field a little differently than the standard model predicts.
And that's led to all this speculation about new physics, new supersymmetric particles that we haven't discovered yet.
The Fermilab experiment keeps confirming this tiny difference. How does UCF explain it without inventing new particles?
It says the problem isn't missing particles, it's an incomplete description of the vacuum. The fractal dimension of time introduces a scaling factor, n, into the quantum field theory calculations, specifically for the most complex terms.
So what is this scaling factor?
It's derived as n equals nu to the -1, which is just the golden ratio itself.
Yeah.
About 1.618.
So the very geometry of time, governed by 1.618, subtly changes the internal calculations for the muon's magnetic moment.
Yes, and when you apply that geometric scaling factor, the theoretical prediction from UCF aligns perfectly with the excess that Fermilab has measured. It suggests the tension was never about missing particles, it was a geometric error in our old math.
So we've gone from the cosmic expansion down to the wobble of a single subatomic particle, all supposedly connected by nu and pi.
That's the claim. And the defining feature of this whole theory is its insistence on being testable. The falsification matrix, what they call the Kruppstahl check, is what gives it scientific integrity.
Let's just review those two kill switches one last time for everyone listening.
First, the big cosmological test, the Euclid mission. The data has to show W0 is around -794 and WAS is around positive 0.127. If Euclid comes back and says W0 is -1 plus or minus a tiny error bar, the theory is false.
And the second one?
The solar system test. The deep space network chronometry. The teams have to find that 61.9 microsecond per year drift in the raw Doppler data for Mars. If that signal isn't there, the theory is refuted.
If this is confirmed, it's a complete paradigm shift. It replaces the entire particle zoo of the dark sector, that 20-plus parameter model, with a clean, zero-parameter geometric necessity.
And its elegance is measurable. The sources point out that when you model galaxy rotation curves, UCF achieves a data compression rate, a minimum description length, that's over 25% more efficient than lambda CDM.
The universe is just mathematically simpler than we thought.
Unfolding in fractal time, bounded by spherical space.
So let me ask you the big final question. What does this geometrically defined universe mean for our ultimate future? If dark energy is driven by the golden ratio, do we still have to worry about the big rip where everything gets torn apart?
Well, the predicted value of W0 being greater than -1 already forbids a big rip. But the ultimate fate described by UCF is something they call the crystalline freeze hypothesis.
A crystalline freeze. That sounds dramatic, but maybe less violent?
Much less violent. As the universe gets older and keeps expanding, its total accumulated history, the sum of all those fractal information units, gets closer and closer to the maximum density allowed by the holographic limit of the cosmic horizon.
Oh, hey.
When that ratio gets close to 1, the fractal time exponent, nu, asymptotically decays to 0.
The flow of time itself stabilizes.
Yeah.
It stops being dynamic.
Exactly. The expansion slows, it stabilizes, and it finally stops. The universe doesn't tear itself apart. It achieves a total final geometric equilibrium. It becomes a perfect static archive of its own history and geometry. A true block universe that's not formed instantly, but through billions of years of dynamic fractal evolution.
That is a staggering vision of geometric inevitability. The universe destined to become a perfect frozen memory of itself, all dictated by the most efficient ratio for growth. Thank you for joining us for this deep dive into the zero-parameter limit. We strongly encourage you to explore this idea of historicity and to keep a very, very close eye on that incoming data from Euclid.